In this short video, I'd like to talk you through how to access and process some of the data that you get from your mini GC analysis. So I'm looking here at our Chem 212 lab page, and in particular under the dehydration tab. Scrolling down. First of all, I wanted to indicate that I've updated the lab6 schematic because the analysis via the mini GC changed a little bit. So this page is updated, so please consult it. The update mainly had to do with, instead of diluting the alkene sample, we injected it directly. We injected 0.2 microliters. These are the conditions by which the mini GC or the GC mini was run. Okay, so that's one thing that you should take a look at. We also have here the student data, and I will take a look at that in a minute. We have a spot to download the graphical analysis program. I did want to show you also, however, right here, the mini GC reference file. So I've updated that as well. And the reason why I did that is because I did not want to have a solvent peak, which you will no longer have. And I wanted to give you an idea of how you should be annotating your own file. So in a minute, I'll show you what your file or what your chromatogram looks like. But you will need to make sure that you include the appropriate name, what the area is in the peaks, and at what time the peak eluded in the chromatogram. This table will already be in your chromatogram. Now, one of the things that you'll notice is this sort of file will be available to you, and the y-axis here is normalized range, the x-axis is time in minutes. I had to adjust the time in minutes so that it read properly like that, and I'll show you why in a minute. The reason why we give the area in just these units values, because this normalized range doesn't really have any actual units. So that's a reference file against which you can compare when you're looking at your own data. So Vernon student data, so I'm going to click on here, and you'll see that there are two forms of the student data. One is a PNG file. So for instance, I'm going to open up the data from Alex, Hannah, and Area. And there it is. Okay. So you'll see that I've had to adjust this a bit. I took the original data and cut and pasted in here and had a properly labeled y-axis, x-axis, and I've included the conditions under which the run was done. Further annotation, however, is necessary. So let's take a look. The other way that the data is presented to you is right down here as a GAMBL file. So that's the one that corresponds to Alex, Hannah, and Area. Once again, you can download this file. So if I click on here, it shows up here. It will download to my downloads folder. Now, you're not going to be able to just open it directly by clicking on it in the same way that you can open up a PNG file with some sort of photo viewing software. So download it somewhere. Right now, it's downloaded in my downloads folder. If you need to move it somewhere in a working folder, but just know where you've downloaded your data folder. Next, I'm going to assume that you have installed graphical analysis. Next, I'm going to open up graphical analysis. So I'm going to click here, let it open up, and I'm prompted to choose a file. Now note, this is a free version of the graphical analysis, and it doesn't allow you to do everything that you would do in a paid version. And I'll show you one of the issues related to that. So we're going to choose a file. And in particular, I'm going to look in my downloads folder for that file that I just downloaded. Actually, well, I'll show you where that is, first of all. So downloads folder. So there it is. So that would be the file that, let's say if Alex was downloading or Hannah or Area, then they can then open up their data and work with it. What I want to show you, though, is a different one to work with. In particular, I'm going to show you how I worked with the standard. So I'm going to open up the standard file. So open up. And we end up with something like this. So your data should look something like this. Now, you'll see that it looks a little bit different than the PNG file in the sense that I have here on the side here normalized response. And so it's not as properly labeled and problematic. We have down here time, but it's in seconds. And for whatever reason, that's the default, and we're not able to change this. Maybe just to give you a heads up over here, I can choose a data table that shows the data in table format. And it's in seconds. And then if I try column options and try to change the time, I can't. So that's because this is the free version. So don't worry about it. You don't need to change it because I've already modified the file for you. So I'm going to get rid of the data table. The only reason why you're opening it up here is I want you to get some information. That is, I want you to get the exact time that the peaks have eluded, and I also want you to get the area. Now actually we have 3 peaks. We have a really tiny peak here, which is one of the side products. Here's the main product, and this is the original reactant. So the idea is that you want to, let's say, first of all, find the time. And so you're going to kind of click near where you think the peak is. And I notice, okay, the time here is about 3.6 seconds listed here. Note that that should be 3.6 minutes. That's what you would record. And then I can sort of guesstimate, well, the next one is here around 4.6 seconds. So it should be 4.6 minutes. Click here. Maybe I need to move it along a bit. So kind of guesstimate, where is the peak at its maximum? Let's say 9.8 seconds, and I would record that. There would be some margin of error if 2 people are doing this, which actually everyone should try on their own. You might get slightly different results depending on how you estimate. That's one of the things you need to estimate. The next thing you need to estimate is the area under each of the peaks. Here again is some guesswork. So the idea is I'm now holding down the left button of my mouse and dragging. And actually I don't quite like that. I think I've cut off the peak a bit. So I'm going to just kind of move it along. And you can see what I mean, that we're kind of guesstimating where does the peak start and where does it end. I think I got it a little too wide here. What do you think? That looks pretty good. How about this? Yeah, that looks pretty good. Again, it is a bit of an estimation, so each student will get a slightly different value. When you finish dragging, you're asked to whether you want to do any of these things, and what you want to do is view the integral. So I'm viewing the integral, and note it's given in units of seconds. Again, that's not what you want, so I've translated this to just simply units. Okay, so I would have reported this as 4,053 units. Okay, so round to the nearest integer. So you'd be recording that. I'm going to come over here and try to estimate where the peak is. So something like this. And view the integral. So that would be around 2,567. Again, units. And then finally, there is a peak here, and I'm just going to drag along, something like this, and view integral, and I get around 17 seconds. I think you'll find that this is pretty consistent with what shows up in the actual reference file that I have posted. So those 2 things. Number 1, you need to find the exact time that these peaks eluded, or at least where the maximum part of the peak eluded. And then next, you need to find the area. Now, just a small note about what to do with these areas. I think there are 2 things, actually. One, you can simply look at the products and get, in a sense, a percentage of how much of the major product is produced compared to the minor product. So you can compare those. But I think it's also interesting to find out or make a comparison amongst all the peaks. and say, well, what percentage are the products and what percentage is the remaining reactant? How much reactant did not react as a percentage? Okay, so I'm hoping that this video has helped you think about how to work with your data. And of course, if you have any questions, don't hesitate to ask.